In this video, we're interested in developing the idea of integration by parts. And we start that by first remembering the product rule for the derivative. So let's say we have two functions, u and v, and we want to take the derivative with respect to x, where u and v are both functions of x. We know that we take the derivative of the first, so du dx, times the second, v plus the first times the derivative of the second, dv dx. Now, if we group these together so that we have this on one side, so u dv dx is equal to the derivative with respect to x of u times v minus v times the derivative of u with respect to x. Now, if we come over here and we integrate both sides now with respect to x, so let's change that color here, dx, integrate dx, integrate dx. Well, those cancel, so we're left on the left-hand side with u dv equals, and the antiderivative of the derivative, those just cancel each other out, so you're left with u times v minus the integral of v du. And so this is the formula for the integration by parts. So if you can take an integral and you can assign part of it u and the rest of it dv, then this is a way to solve that integral. So let's look at some examples. Often when we have polynomials and transcendental functions, like trig functions, exponential functions, so if I had something like x ln of x dx, well, here I have to decide, and so my goal is to assign some of it. You want to assign a piece to u such that du dx isn't worse, hopefully better, and dv such that the integral of dv isn't worse. So it's kind of a fine, a subtle process, but we do have some guidelines. So in general, if you have logarithms, so I'm going to write this in this order. So logarithms, inverse, trig, polynomials, trig functions, and lastly, exponentials. So the deal is that if any of the pairs of these appear, you're going to let u be the one that's on top and dv the one that's on bottom. So for example, right here, x ln of x dx, logs are above polynomials, so we're going to let u be ln of x and dv be x dx. Let's see if this works for us. So if we let u be equal to ln of x, then du is 1 over x dx, dv is x dx, so v is x squared over 2. All right, then we solve this problem. So remember, it's u times v, so ln of x times x squared over 2 minus the integral of v, x squared over 2, du, 1 over x dx. Now that simplifies nicely. Let's rewrite it here, ln of x over 2. To pull out my 1/2, that x cancels, and I'm really just integrating x dx. So in the end, I get, that's an easy integral left over for us, ln of x over 2 minus 1/2 x squared over 2, and don't forget plus c. Go practice.